Hello 108 class, Mr. McHugh here with you on section 9.6. We are going to kick this off and we're going to talk more about parabolas. And page 1, we're going to focus on finding the line of symmetry and the vertex, which is the lowest or highest point on the parabola from our quadratic equation. Okay, so hopefully this is going to flow okay here. So let me just kind of get started. You know that the vertical parabola has got the form f of x equals ax squared plus bx plus c. That's standard form. And you also know, and that's all stemmed from my examples, y equals x squared. And you know that the solution from the quadratic equation way back beginning of section 9 here was x equals, now my form was negative b divided by 2a, and I kind of told you I like that because that was the line of symmetry right here. And so I kind of want to try to prove that to you here today. Then it was plus or minus, and here's your big square root. Everybody remember what this is underneath it? B squared minus 4ac. Hopefully you're saying the discriminant. Okay, so you have that in there. Now what would be nice is how in the heck do you go from standard into the graphing form? I'm calling this graphing here so we can distinguish. And you, from our last section of 9.6, you know we've got the parentheses with the coefficient a times the parentheses x minus h squared plus k. And what was the beauty of it? The vertex was real easy. You took the opposite for the horizontal and then you brought down the vertical, the constant. And how you go from standard into the graphing form is to do the completing of the square method. Okay, now a couple things here. What I want you to realize here is that to find the vertex, the easiest way to do it is to know that the vertex is negative b divided by 2a. Okay, now I want to prove that to you with this completing the square method. And we're going to do an example when the a coefficient is 1. If you like the completing of the square method, you could use it. Most students don't bother with it. But I want to use it to prove to you that the line of symmetry is negative b divided by 2a. Because that vertex is the x-coordinate, the line of symmetry, which is vertical, is going to go through the h portion of the vertex, which is the x-coordinate. Tongue twister there. Okay, so here we go. So what I want to do is go ahead and show you example 1, and you only want to use this completing the square technique when a equals 1. Okay, don't bother. I have an example we're going to do. I'm going to skip it. It's too much of a pain in the butt. Okay, it's not worth it when you can practically memorize negative b divided by 2a. And if you've been writing the quadratic equation the way I recommended it, you've already got this. So here's the deal. You figure out the square, completing the square, determine the fudge factor or the squaring factor. What that is look at the middle term, the coefficient 4, take it, cut it in half, and square it. Do you remember that from before? So b divided by 2 squared is the fudge factor or squaring factor. So in our case, a is 1, b is negative 4, c is 5. I like to put those in a box to keep remembering them. And so real quickly, you figure out the squaring or the fudge factor, and you get what? Negative 4 divided by 2 is what? Negative 2 squared, and you get what? 4. Okay, I didn't write that in there, equals 4. Now, what are you going to do with it? You're going to write yourself a set of parentheses around x squared minus 4, going to leave a little bit of a space, and going to put the plus 5. And you are going to add the fudge factor, the squaring factor, inside the parentheses. Okay, you're making a perfect square trinomial. However, you just can't willy-nilly do that. If it's a plus 4, you have to balance it, but counterbalance it with a minus 4. Does everybody see that? Okay, now this technique here, again, I recommend you only ever use this when a equals 1. Okay, now, so with that said, guess what you can do now? Your trinomial is a perfect square trinomial. Factor it into square root of the first term, square root of the second term, and you've already met the doubling it equals the middle term minus 2x, so you're good to go. And what's left on the outside? Negative 4 plus 5 is 1. Okay, that's how you make that transformation. And I like showing this because now you're looking at here, where's the proof is in the pudding. What is the vertex to this problem? Okay, vertex here would be what? H comma k, which would be the opposite of the inside the parentheses. So there's your plus 2 comma 1. Okay, you're done. So Instead of giving it to us in the graphing formula, you get it to a standard form and you have to convert it. Okay, that's nice that we can go through that process of a equals 1 and it's not too bad. Okay, now what I want you to do real quick is off to the side here, work the line of symmetry, the x component or the h of the vertex. So it's negative b divided by 2a, and if you didn't go through this whole completing of the square, you'd come up here and use this. What would you get? So a negative of b is a negative 4, so you get a negative of a negative divided by 2 times a, which is 1. You've got what? A positive 4 divided by 2, and you get 2. Oh, look at that. A positive 2. Does that match our x-coordinate of the vertex, the h? And the answer is yes. Now, how do you get... Now, if we take the time... If we took the time now... In fact, I'm just going to do it. Now, you know h comma k is 2 comma 1 from our graphing formula. Now, this up here is telling you to go ahead and take 2 as your x. F of 2 is going to be plugged into the equation. Now let's see, where can I work this at? Oh, can I squeeze some room here? Oh yeah, down here. So here's what we're saying. We are now going to say, what's f of 2? We're going to go back to the equation, which is x squared minus 4x plus 5. We're going to substitute 2 in. So here we go. 2 squared minus 4 times 2 plus 5. Okay, bear with me, class. I'm going to have to go this way. Sorry, what do you get? 4 minus 8 plus 5. Do we get 4 plus 5 is what? 9 minus 8. Bingo. What do we get? 1. And that is our y output, which is the ordered pair x comma y. So there's the proof right there. Okay, hopefully you see that. I recommend find a line of symmetry, get used to doing negative b divided by 2a. Okay, hey, we've done our first page. We're on our journey here. It's going to be a little long. Hang in there with me. We'll do this and we'll be in good shape. Okay, Mr. Q going to sign off for now, and I'll see you for page 2, and we're going to go ahead and do a couple problems where you use that line of symmetry to find a vertex. Okay, take care. Bye.